First part of our presentation will be about the integration of systems, or what we call building systems integration. We, as architects, have witnessed big changes in the design of buildings and complication of systems that are involved. So, and it's no longer sufficient just to draw some walls and columns in the design. We have to think about the systems that will be involved in the building and how to make them all work together in harmony and integrate them in the design. So buildings are no longer just walls and doors and floors. They are systems, as we will see now. We need the systems for lighting in order to have proper lighting levels. We need the systems for air quality, environmental control. We have air conditioning, we have heating, we have ventilation. So all these are important. We have systems for firefighting, sound systems, IT,
lighting.
Lighting, yeah, not lightning, lighting.
Sorry.
It is, all these systems, we have to think about them from the beginning of the design in order to be implemented successfully and work in harmony when we design. So buildings now are like machines. They are involving many types of systems that they work together all the time. So there is a structural system, there is a mechanical system, HVAC system, conveyor system, surveillance system. So they have many elements that we have to think about from the beginning. So we have mechanical systems, we have interior design that we have to think about, the reflected ceiling, the elements of interior, and how will we provide lighting and air conditioning for them. The building envelope, how does it impact the interior environment, the structural system? All this requires integration. And there are three elements that are always conflicting, or that we always think about. The form. As architects, we are interested in making the best form and shape, but there is also cost. We have to think about cost. Inshallah, when you graduate, you will find that the client always talks about cost. So you have to think about cost of building and systems at the same time. And the last element that you will...
Doctor.
Yes.
صوتي قطع شوية, I think.
طيب. Okay, just a minute كده. As we said that there are three main determinants of the systems. We have the form of the building, the form of the building, the cost of the systems involved, structural, mechanical, electrical, and so forth, and then the performance of the building. The performance will last for a long time, 10, 20, 30, 40 years. How will the building perform, and how will it cost during the for its maintenance, replacement of systems, and so forth. So the buildings are now more complicated than just walls and floors and ceilings. These systems are all involved. Our mechanical systems are a major element in the building nowadays. They constitute more than 30% of the cost of office buildings. So when we look at them and try to make them efficient and productive. So we are impacting the initial cost of the building and the running cost afterwards. طبعا also the structural system makes about 30-35%, finishing about 8 to 10%, and then you have the equipment and many other elements. But mechanical systems, they take about more than 30%. So what happens if we don't coordinate? So if we don't coordinate the design from the beginning, we
دكتور في مشكلة بالصوت عندك.
الصوت والله I'm using the phone with 4G.
الصوت كذا مرة بيشوش.
Let me try to... No, but I'm using the 4G. It's supposed to be the best يعني what can you do?
أيوة لا هو مو من النت أتوقع من السماعة.
يعني is that better now كده؟
لا هو صوتك كلير بس كذا في صوت تشويش ورا صوتك مرة قوي.
I don't know. طيب that better?
أيوة.
Okay.
Thank you.
All right. If that is better, let's go. طيب let's go back to the presentation. I think it stopped. So do you see my presentation?
Yes.
Yes.
Okay. So if we don't coordinate the systems from the beginning of the design, what happens is that we tend to make the aesthetics, the form override the performance, which طبعا will result in cost overrides the performance afterwards. So we have to balance between the aesthetics of the building and the cost of running the building. So the performance will be special. How does the circulation, the movement in between the functions? It will be thermal, heating, ventilation, air conditioning, air quality is very important, especially in office buildings. Sometimes if someone cooks something or heats something in the microwave, the whole office will smell it. Acoustical, because when you have open office plan, you will suffer from acoustical problems because people can hear each other, they can hear discussions, they can hear phones ringing, they can hear all the conversations will be echoed. So we have to use materials that does not reflect the sound to the space or to other people. طبعا visual connectivity or visual disconnectivity, or do you want people to see each other in the office, or do you have cubicles or partitions between them? So because of distraction and so forth, طبعا this affects the integrity of the office and how much do you want to see it visible or not visible. So in a successfully designed project, building systems, materials, products must be integrated from the beginning to create a unified whole that achieves the desired functional purpose. An integrated solution results from a design approach that considers the characteristics of each component proposed in the project and searches for opportunities for dual functions or for sharing of volume. So that's why we stress the issue of integrated building systems. Now we teach the course comprehensive design. Some universities call it integrated design. It is the same idea that design should address all the systems from the beginning. So as we see here, there are many systems that are involved in the design of the building. We have HVAC, we have firefighting, we have security, we have digital cameras around the building, we have security of intrusion detection of people coming in, we have fingerprints of finger signing for the employees. There are many systems, and there is always in these big buildings there is a room called the control room. All the systems, they go to this control room, and they are monitored by a special team who takes care of the lighting, the firefighting alarms, the cameras, the access control. There is a control room in the building. طبعا the first and simplest system that we deal with is the air conditioning. As you see, basically there is a supply and return. You bring air to the room and you take that air back to the system again, where it is re-cooled or reheated and mixed with some fresh air so that there is always proper level of oxygen in the air. That's why we need the false ceiling. So the false ceiling will cover the ducts that will be running in the ceiling to provide the air and take the air back. So as you see in the diagram above, there is a duct coming from a vertical duct. So there is a vertical duct that brings the air from the chillers and returns the used air back again. And then there is a supply diffusers in different places where it gives air to the different areas. طبعا some systems, they have the return, which reduces the cost. Some systems, they just let the air go out by the difference in pressure. But this diagram, can you all see the diagram?
Yes.
Yes, yes.
Okay. So the diagram here shows how the fresh air comes to the system, and then it starts to be pushed by the fans to the ducts. The blue is the cold air. And the cold air goes to the ducts, and they start to get smaller and smaller and smaller until they reach the desired room. And then there is the diffuser that diffuses the air to the rooms. But then there is a exhaust where the air goes back to the return duct, and then it is collected back again to the air handling unit. The air handling unit mixes the used air with fresh air. So it takes the air out and then takes some of it back. Usually the ratio is 30%. If it's less than 30%, people will start to feel dizzy. They start to feel that there is not enough oxygen in the air.
30% of oxygen?
30% of fresh air. طبعا the problem of getting fresh air is that it is مثلا in the summer it is very hot, it's 40 degrees outside. You want this air to be مثلا 20 degrees. It goes to the rooms and you get it back as مثلا 25, 27. And then when you mix it with fresh air, completely fresh air that is 40 degrees or 45 degrees, then you will need the machines to run more to cool it down. So you know,
we need bigger machines.
It's cost benefit calculation. طبعا the mechanical engineer will do this job for us, and they calculate how much is the cost and the capacity of the machines and so forth. You just need to understand the concept. So when you discuss it with the mechanical engineer, you can have positive influence. This is a picture of an exposed system in a roof. طبعا we have the structural system, the roof itself, and the beam, and then these are the supply diffusers that are hanging in the ceiling. طبعا this is usually the size of the acoustical tile, 60 by 60, so it diffuses the air to the room. So when you design the false ceiling, you select the 60 by 60 tiles that will have this supply diffuser. The supply diffuser is getting the air from a duct. The duct is connected to another duct, to the main duct, and so forth. And then all this is covered by the false ceiling of acoustical tiles or gypsum board and so forth. Another important system, yes.
سوري بس تقريبا كم الهايت حق الفول سيلينج دائما يكون 30 ولا 40 سنتيمتر او 20 سنتيمتر اتوقع صح؟
الفول سيلينج؟
ايوه
لا طبعا it's much more يعني it's usually 60 to 100 كمان يعني
صح؟
it depends.
ايوه
شوفي it depends on the size of this duct. If this duct is big, then we need to have a larger force. But it's minimal. يعني 60 is minimal. Look at the the supply diffuser, and it has a box on top of it connected to the duct. But then you still have, as we will see, the firefighting system, and you have the lighting system.
يعني لو التوتال هايت is 4 meters حيكون الكلير هايت 320 meters مثلا.
مثلا
Another question, sorry.
Yeah.
If you have exposed ceilings لازم نرسم الducts ceiling plan صح؟
طبعا if you have exposed ceiling, then you will have to draw because you will design how these ducts will be constructed, because it's part of your design. So you will need to show how the ducts will be, because they have impact on your interior.
Yes. Okay.
If there is a full ceiling, خلاص, no problem, because they will all be covered so we'll leave that to the mechanical engineer and the contractor. But if you want them to be exposed, then you have to make sure that they look the way you want them.
Another question, what's the diameter of the ducts?
The ducts, we have another slide that shows the diameters and sizes. طبعا at the last diffuser, this is the minimum, 20 by 30, something like this. But when you have two sub diffusers, then the duct between them will be مثلا 30 by 30. وبعدين it starts 30 by 40 and 40 by 40
ما
so
فهمت.
that it carries the volume of air that is required for each room.
Okay.
So I will show you a diagram now that has the dimensions. Yeah.
تمام.
طبعا the other system that is extremely important is firefighting, what you call FF. So firefighting, we have to provide the fire hydrant with the fire brigade with inlet of water. So when they put their cars, they have to have air pressure, water pressure here to fight the fires in different floors. So these are pipes that are sometimes they are empty. We call it dry rising. So when there is the fire brigade comes, they connect to it and provide water. Sometimes this is continuously water pressure pipes. So you have to think also about the firefighting. This is another system of what we call sprinkler systems. So here, all these pipes must be pressurized all the time, because when a fire happens here, the bulb will explode and the water will start to come out, as you see in the picture below. So the water will come from these sprinkler heads. So the water here has to be controlled and under pressure all the time. So this is another system that we have to think about, how the distribution of this sprinkler, because each sprinkle covers 2 to 2.5 meters of diameter. So you need several of them to cover the floor plan. They don't cover the whole area. Each one covers a diameter of 2 meters below it. طبعا there is an inspector test connection, so they make sure that the water is always pressure in the pipes. Another system that is becoming important is the sound system for announcements, for music, for entertainment, for anything. As you have in the university, there is a sound system that gives announcements to the students, airports, hospitals, office buildings. So sound systems are also becoming important. So in buildings, security and surveillance is becoming more and more important. There are cameras everywhere for monitoring the people in hotels, in malls, in airports. There are surveillance cameras everywhere. So you have to design the location of the surveillance camera so you have enough coverage of the area that you have in terms of entrances, corridors, doors. So this is also another system that has to be integrated. So all these, you see these half domes that are hanging from the ceiling. These are cameras that cover the whole area in libraries, in hospitals, and everywhere. So you can have, you as an architect should select the proper location for the cameras and how they are covering the whole, most of the area, and having good coverage of the place. So smart buildings, as we call them, they are mainly system integration. of all the systems that are available in the building. So they all work together. They are all controlled from a control room. طبعا we still have IT systems. We have telephones. We have internet connections. We have routers. So all this is part of systems that are covered. طبعا last time we talked about the suites catalogs, the suites.com, and